Organizers of the music festival charge $60 for admission. The organizers polled the attendees to determine how increasing the price would affect the attendance. The equation P of X equals negative 20,000 X squared minus 20,000 X plus 600,000. Model the profit of the function of X where X is each $1 increase in the admission fee. All right, so if X equals 2, the admission fee is going to increase by $2. Stop, please. Stop. Okay. X is $1 increase in the admission fee. So if X is 2, my ticket has increased by $2. So what is my new ticket fee going to be? So now it's going to be $62. Okay. No. Nope. We just had to pay attention to what represented what. So now we're going to solve it by factoring. Okay. We're going to solve by factoring. Negative 20,000 X squared minus 20,000 X plus 600,000. What do you think we're going to do first, friends? Greatest common factor is going to be what? Negative 20,000. So let's take out negative 20,000 from everything. You should be left with X squared. Then what? Plus X. And then minus, what, 6? No, that's dumb. It's not 6. 30, yep. 600,000 divided by 20,000 is 30. There we go. That makes sense. All right, so does that negative 20,000 do anything to my factors? No. Or to my solutions? No. It is a scalar technically, but that does nothing for me. So what multiplies to give me negative 30 but adds to give me a positive 1? Positive 6 and negative 5. So what are the solutions going to be? X equals negative 6, and over here X equals positive 5. So what we're going to do today is now we're also going to interpret those meanings. Okay? So because X is a $1 increase to the admission fee, what does it mean to have X equals negative 6 as a solution or X equals positive 5 as a solution? If X equals negative 6, the price decreased by $6, right? But when X equals positive 5, what is that representing? The price is going to increase. So if the price decreased by $6 and if the price increased by $5, what does that mean to my profit of this music festival? Solutions are when Y equals what? When Y equals 0. So if I decrease the ticket by $6 or if I increase the ticket by $5, what is my profit going to be both times? 0. It's going to be 0. So if this happens, profit will be $0. Do you know what profit means? Make money. Okay? So if they're trying to adjust their ticket price to maximize their profits, if they decrease the ticket price by $6 or increase it by $5, they've gone too far, they're back at 0. So yeah, they're trying to use this equation to help to maximize their profit. So I would assume it's the vertex of what this quadratic would be. Yes, no, maybe. You probably did a little bit of that in Algebra 1. Okay. Moving on to number 2. We're going to do some more solving and then interpreting. The compact disc, otherwise known as a CD, I don't know if you've heard of these things, was invented in 1979, many years before online music existed. At the time, it was the most sophisticated way to store and play music. In 1982, CDs were made available to the public. CDs quickly became the most efficient way of storing music, which replaced vinyl records and cassette tapes. The function C of x equals negative 2x squared plus 38x plus 40 models the sales in hundreds of millions of dollars of compact discs in the years since 1990. All right, so let's solve. We're going to solve this equation. It says by factoring. So what can I do first? Let's divide it all by negative 2. Yep. So if we divide by negative 2, we get what? X squared. And then what goes in the middle? Negative 19. If my pen will work. And then what's on the end? Negative 20. All right, so what is going to multiply to give us negative 20, but add to give us negative 19? Negative 20 and positive 1. So what are my two zeros? X equals 20 and x equals negative 1. Good. How come I don't say x equals negative 2? Does negative 2 have an x? No. So is it going to give me a solution to my problem? No. I don't care about it. GCX, we take them out. Goodbye. Good riddance when we're solving. All right, part B, we're going to interpret the year that each zero represents. So we got x equals 20, and we got x equals negative 1. So what year are we talking about if x equals 20? What's that? Let's see, look. The year since 1990, right? So if x is 20, we're looking at the year 2010. Good. And then what if x is negative 1? 1989, where Miss Douglas was 1 year old. Ooh, ah. All right, so what does that mean according, like in context to the sales? What are the sales of my CDs in the years 2010 and 1989? There weren't any. In 2010 and 1989, sales of CDs were 0. Okay. In 2001, iTunes was launched by Apple. For the first time, people could buy songs online and store them on an MP3 players, iPods, or on a computer. Then, in 2008, the music streaming site Spotify started. Discuss with your partner why one of these zeros shows that the online access to music may have led to CD sales eventually reaching 0. So talk to your neighbor. Which one of our solutions could show that? Okay, so does x equal negative 1 or does x equal 20 represent the demise of CDs? X equals 20 makes sense, right? 1989, CDs were definitely still a thing, right? Where did it say? CDs were made to the public. Did it say in 80? Oh, 82, right? So CDs were very much still a thing. 2001 came, and then 2008, so x equals 20, which represents the year 2010, right? This is 9 years after iTunes. So it would make sense that the CDs were gone. Okay, so the sale of CDs were no more. So that one is the one that would make sense to our problem. Okay. So I wanted to know which one of those represented the CDs going away because of iTunes and Spotify. The x equals 20 would make the most sense for that. Okay. Because we get quadratic equations, these are just models of predicting things, right? They're not like actual data. They are fitting a prediction of what could or could not happen. So it wouldn't make sense that 1989 really showed CDs not existing. They definitely did exist. All right, number 3. A statistician gathers data over several years, starting in 1995, on the average number of trips a household makes to run errands. The statistician uses the data to find the equation E of x equals negative 2x squared plus 68x plus 480, which models the average annual number of trips for errands per household for the years since 1995. All right, the graph of the equation is shown. Interpret E of 12 and include units. So it's kind of blurry on my screen. It's a little bit better shown on your paper. It says 12 and then 1008 is what that point is. Okay. So first off, E of 12 means it's been 12 years, right? 12 years since what? Okay, since my data started. 12 years since what year? 1995. So if it's been 12 years, y'all listen. If it's been 12 years since 1995, what year is it? And this is the year 2007. So in 2007, the number of errands was what? Number of errands was 1008. So they're saying 12 years after the study started, so in 2007, that's 12 years past 1995, that the average number of errands, is it year? The average number of trips a household makes to run errands is I think it's per year, is 1008. All right, let's determine the zeros of the function. How can we figure that out? Yeah, let's look at our x-intercepts. This guy is pretty obvious. This is going to be x equals what? 40. Good. This one we're going to use our best judgment. Negative 6. Sounds good. X equals negative 6 and x equals 40. All right, so now what we're going to do on the back, so it's the same graph, C and D go with the same problem. So we're going to interpret both zeros in terms of the context. So we're interpreting x equals negative 6. We're interpreting x equals 40. So if we have x equals negative 6, what year am I looking at? Yes, 1995 minus 6. That gives me 1989. And what's the other year we're looking at? 2035. So x equals negative 6 is showing 6 years before the study started. X equals 40 is showing 40 years after. So what does it mean for those 2 years if those are my solutions? There were no errands. Has 0 errands. All right, let's talk about it. Does it make sense that both, whether or not both zeros are viable? Would it make sense that a household has 0 errands to run? An errand would be, running to the store or picking up something or sending a letter out. Anything that you have to go do real fast. It would make sense to never have anything to do. Okay, but you still would have to go do, you'd have to, okay, the errand might be making the order.
That's not really an
You
errand.
still have to do something.
An errand is going to the store and buying something and like going out to get food.
What about picking up your dry cleaners? What about taking your kid to school? Picking your kid up from school? Hey, fun fact, I know you don't have a household yet. There will always be errands to run. Always. There will always be errands to run. Okay? So both are non-viable. You will always have errands. You will always have errands. You will always have something to do. Pay your bills. Something. Questions on the errands problem? The equation h of x equals, y'all, please stop, equals negative 16x squared plus 64x plus 192. Okay, this models the height and feet of a toy rocket after x seconds. Okay, that it is launched from the top of a 16-story building. Determine the zeros of the function and show your work. So what should we do? How do we determine zeros of a function? We factor, yes. So I have negative 16x squared plus 64x plus 192. How are we going to factor this? Yeah, we can divide everything by negative 16. Right, so negative 16 divided by negative 16 is 1. What is 64 divided by negative 16? Negative 4. All right, and then 192 divided by negative 16? Negative 12. All right, beautifuls. What multiplies to give us negative 12 but adds to give me negative 4? So negative 6, positive 2, right? Negative 6 times 2 is negative 12. Negative 6 plus 2 is negative 4. So what are my zeros for the function? X equals positive 6 and x equals negative 2. All right, let's interpret that with our problem. We're talking about a rocket, right? A rocket's being launched. It gives me height, it gives me time. So we should use all of that to interpret our solutions. Okay, so if we have x equals 6, x equals negative 2, is that giving me height or is that giving me time? It's giving me the time. Okay, it's giving me the time. After x seconds, right? After x seconds that it's launched. So if x equals 6, it's been 6 seconds since I've launched it. If x equals negative 2, that's something different. Where is it? If y'all weren't talking so much. It hits the ground. Yes, we're equal to 0, right? If we're equal to 0, my height is 0. Yes? So my rocket is on the ground at negative 2 and 6 seconds. Okay. Are both of these solutions going to be viable? Which one is not viable? Negative 2 is not viable. How come? Time, not yet. We cannot go back in time yet. Okay. So with my time being 0, that shows when they actually launched the rocket. So negative 2 is not viable. Because that would be before the rocket even launched. Okay, before launch. 6 is viable. That is 6 seconds after launch. So if I drew a picture, here we are in the building, here's the rocket, right? That would be my x of 6. It wouldn't make sense to go backwards in time with -2. Can't do it. You ready to try one? It's happening. Here we go. Number 5 is all yours. A firework is launched from a hill that is 80 feet above a lake. The firework will descend into the lake after it has exploded at its maximum height. The firework's height in feet above the lake surface is given by h of t equals -16t squared plus 64t plus 80, where t, that should just be 1t, not 2, where t is the time in seconds. All right, so you and your partner, you're going to determine the zeros of the function and let me know if one, both, or none of them are viable in this situation. All right, when you factored, you had a GCF, yes? It was -16. So when you factor what you had left, you should have gotten t equals -1 and t equals +5. Does anyone need me to see how to get those? Okay. So of those two, since we're talking about time, we cannot go negative time in this context. So t equals 5 is the only viable solution because that shows the firework hitting the lake 5 seconds after its launch. Yep. So you have to divide everything by -16. So you have t squared minus 4t, and then this becomes -5. So we did t minus 5 and t plus 1. Yeah. So that's how here you get +5 and here you get -1. Okay. We got any questions? All right, you have a worksheet 1 through 10 that we should work on. Okay. Tomorrow we're going to do more of this, but we're going to solve with graphing, so it'll make your life so much easier if you have a graphic calculator. All right?